Owen and I are going to play a game called Two Turns to Build. We're each going to take 2 turns. We're going to build our number, and then we're going to show you how we're going to put those two building turns together into a larger number, and then we're going to compare what we got. So we're going to show you how to play. I put the pages from your student book that have your 2 turns to build board and also a score sheet. I don't have a printer and I don't have the student book, so I made my own. All I did was write 2 turns to build at the top. I made 4 boxes and then 1 big box at the bottom. So here's going to be my first turn to build. This is for my second turn to build. This is where I'm going to put everything together. And then for the score sheet, I just kind of copied it and I wrote my equation, my partner's equation, and then here at the bottom, I put 2 boxes with a circle in the middle because I'm going to compare my equation to my partner's equation at the end. At the very end of this video, I'll show you how to do a little bit more challenge with it, and it's really just about changing the numbers. So I have a deck of cards. I could use Uno cards too. I had Owen separate the cards out, so I don't have any numbers higher than 6 in here. I am using the ace as a 1, or we're using the ace to represent a 1. And then we have ace for 1, and then 2, 3, 4, 5, and 6. Really, if you want to do an extra challenge, you'll add in the numbers 7, 8, and 9. But you'd need to add more supplies to what you have with you. So we're going to put a stack of cards, 1 through 6, in front of us. Then we each have a collection that represents 10s and 1s. So Owen's collection, he's got 12 smallish, roundish rocks that are all about the same size as each other. And they're going to represent 1s in our number. Okay, so then we've got sticks that are all about the same size. And those are going to represent 10s. So the value of a stone or a rock is 1. The value of a stick is 10. So that means that 10 of these is going to have the same value as just 1 of these. This is a 1, this is a 10. And we're going to do 2 turns to build. If you don't have rocks or sticks, which we all have rocks and sticks outside, but since we're playing, there's just another way that I'm going to do it. I'm using pennies to represent my 1s. And I'm using crayons to represent my 10s. So that means that 10 pennies have the same value as 1 crayon. Okay, so I have my 10s and 1s. Owen's got his 10s and 1s. He's going to put it that way to him because when we write a number, the 10s are on that side and the 1s are on that side. So I'm going to go first. Hi, Monty.
Hi.
And I'll show you how I'm going to have my 2 turns to build, and then he'll do his 2 turns to build. So I pulled a 2 and a 3. So I'm going to read this as 2 10s and 3 1s. This is going to be the number 23. So I'm going to build the number 23. 10, 20, 21, 22, 23. Okay, that's my first turn for 23. I'm just going to show you this way so you see how I built my first number. And then my second turn to build, I've got 1 10 and 2 1s. So I've got 10, 11, 12. Okay, so my job now is to figure out my total. So I've got 23 plus 12 as my equation. I'm going to grab my pencil. I'm writing my equation. I have 23 plus 12. And I have to figure out what the total is for that. So this bottom space is so that I could put all of my 10s together and put all of my 1s together and see what I've got. So 10, 20, 30, 31, 32, 33, 34, 35. So my total is 35. All right, Owen, I'm going to move these and Owen's going to have his turn. Go for it. Show us.
4 tens.
4 tens.
4 ones.
Woo! 4 tens and 4 ones. So he's going to build his first number. 20, 30, 40, 41, 42, 43, 44. And then just how we write our French fries and tater tots, we're going to build down until we get 5 ones and then go up to the top if we have more than 5. All right, will you pull your cards for your second turn to build?
5 tens.
5 tens.
3.
5 tens and 3 ones. Go ahead and build that. 10, 20, 30, 40, 50. And then he needs 3 ones.
1,
Okay.
2, 3.
So he built 53 on the bottom. So while he's putting those all together to see what his total is, I'm going to show you the equation for my partner. This was my equation. 23 plus 12 equaled 35.
I have the equation.
Okay.
98.
Oh, you have the answer?
Yeah.
It's not 98. Try again, but count your ones again. He had 44 plus 53.
Okay.
He knows. He knows what he did.
90.
44 plus 53. And his total is,
97.
will you count that out for us and show us how you know that your total is 97? The total in this addition problem is called the sum. His sum is 97. He's going to show us how.
10, 20, 30, 40, 50, 60, 70, 80, 90, 9 tens and
So 91,
92, 93, 94, 95, 96, and 97.
Okay. So my total was 35, or my sum was 35. His sum was 97. So I'm just going to compare those two here. The larger number is 97. The smaller number was 35. So 35 was less than 97. So he won. I could compare these numbers and figure out how much he won by. So that could be his points for the round. So if I wanted to compare 35 to 97, we could look at his 97 and take 35 away to see what's left. Will you take 35 away and just put it back in your collection? So he's taking away 10, 20, 30. Taking away 1. Oh, put him in. He's taking away 1, 2, 3, 4, 5. So what's left?
50, 62.
Yeah. 10, 20, 30, 40, 50, 60, 61, 62. So we just figured out that he had the greater sum, and he actually had, his was greater by, what was it again, Owen?
62.
Greater by 62. So we're going to do this probably 6 times, and we're going to keep comparing our numbers over and over. The thing that's going to happen if you decide to do an extra challenge on this, that if you start adding numbers that are, let's just say you had an 87, you're going to need at least 18 ones and at least 18 tens. Then you're even going to need something that could represent 100 because you're going to wind up in the hundreds. So you could use something that's square, like the package from the deck of cards maybe would work as 100. So would a small pine cone. That might work too. The other thing is that you might end up, let's just say I had 7 ones for my first number. And then in my second number, let's pretend I had 8 ones. Well, 7 ones, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, and 4. What's going to happen here is that when you slide these down to put them together, if you're using the larger numbers of 7, 8, 9, you're going to wind up with 2, 4, 6, 8, 10, 11, 12, 13, 14, 15. I can't have more than 10. Once I get to 10, I have to do an exchange. So I need to put those in there and trade them for a 10. So I would actually end up with 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So this is where I would need something that was going to represent my 100 so that I could trade these 10 tens for my 100, which I could use a pine cone or something that's a little bit bigger and a little more round or square. All right, enjoy playing. You can play 6 rounds. You can play the regular version with the numbers 1 through 6, or you can play the extended challenge version where you add in numbers 7, 8, and 9. It won't work to use 10s or jacks or queens. All right, enjoy playing 2 turns to build.